Hi guys, welcome back to the Science of Baking. As you know, I'm Kaya. So today we're going to actually review this amazing recipe that's up on the screen for you guys. As you can see, there's 5 stars. It's called Ethyl and Silate's Minty Fresh Cake. It's not going to take too long, but we're going to go through it and just see how it turns out. So let's get started. The first step, we're going to go ahead and preheat our oven to setting 3. You can use an oven or a reflux condenser, whatever you have available to you. And so as we have that preheating, we're just going to let that go while we prepare what we're actually going to put in it. So we're going to start with a 20 milliliter beaker. And we're going to add some salicylic acid into that very carefully so as to not make a mess. We're going to set that container aside for now. Now we're going to add some ethanol, and you might have more than you need, so we're just going to add it a little bit at a time until our solid dissolves. So I added about 5 milliliters of ethanol for that 1 gram of salicylic acid, and that seems to be doing pretty well. So now we're going to take a 10 milliliter round bottom flask. Now this can kind of move around and mix and slosh our liquid. So I'm going to go ahead and put this in a 50 milliliter beaker just to make sure that it's stable and doesn't mess anything up. We're going to go ahead and add our mixture to that 10 milliliter round bottom flask and just get it all in there. So now that we have this mixture all nicely in our 10 milliliter round bottom flask, we can go ahead and make sure that all of those flavors are nice and balanced in there. We're going to go ahead and test the pH. So we don't want to test it directly into our counter because that's going to make a nice mess, and it's not going to be very fun to have to clean up and all of that stuff. So I already have a pH paper in this watch glass here. I'm going to go ahead and take some of this and just put it right on there. And if you want to come in, you can see that it's a pH of 4, which is pretty good because what we're actually going to do is we're going to go ahead and we're going to add some catalyst. We're going to add about 4 drops of sulfuric acid. Now, like I said earlier, you're probably going to have a lot of these ingredients at home, but you might not have sulfuric acid on hand, but don't worry, you can easily find it at Walmart. So we're going to go ahead and go in with 4 drops. And we want to make sure that it's nice and mixed in there. Okay, so now that our sulfuric acid is nicely mixed in there, we're going to go ahead and test that pH one more time to just make sure that our balance of flavors is still good. So I have my pH paper. I'm going to go ahead and throw that into the watch glass. And I can put some of this mixture with the sulfuric acid in it onto that. And you can see that it changed from about a 4 before to about a 2 now. So this is ready to go into our reflux condenser. You want to add a couple of boiling chips just to make sure that it's going to heat nice and evenly and bake your mixture all the way through. So that was in the reflux condenser for about 30 minutes. I've taken it down and set it aside to cool for a little bit. I put it into a room temperature water bath so that it cools a little faster rather than just leaving it out. I didn't want to put it into an ice water bath because that would cause a lot of cracking and a lot of cleanup that I didn't want to have to deal with. So now that it's cool, I can go ahead and remove these boiling chips. And I'm going to go ahead and transfer our solution from a 10 milliliter round bottom flask to a 50 milliliter centrifuge tube so that we can continue to the next steps of our process. Okay, so now that that's in the 50 milliliter centrifuge tube, we can go ahead and add our filling. We have here some dichloromethane and some sodium bicarbonate. It doesn't really matter which order you add it in, so as long as we're careful, we don't want it to spill anywhere. So I'm going to go ahead and put some of this into our tube. Just going to get it all in there. So at this point, we're going to have to look at this, and I don't know if you guys can see from there, so if you come a little closer, you can see that there's a couple of air bubbles here, and we're going to go ahead and we're going to tap lightly, very, very lightly. You don't want this to spill out, and you're just going to allow some time for that gas to escape from the... Okay, so now that we have that nice and tapped, it's really smooth, all that gas has escaped, I went ahead and I scraped off a little bit of that top layer just to test it and see how the flavor was in there, make sure that's the one we want to get rid of. If you look here, we have our pH paper right there. It's at about an 8 right now, which tells me that that is in fact the layer that we want to get rid of. So I'm going to go ahead and take my spoon, or if you guys have a transfer pipette available, you can use that. We're going to go ahead and we're going to scrape off that top layer and just try and get all of it and try and get only the top layer. We don't want to get rid of any of that beautiful wintergreen flavor beneath. We're just going to get rid of that top layer. So now that I've gone ahead and I scraped that off, we can go ahead and add a little bit more of our sodium bicarbonate solution. And we're just going to get that in there. We're going to tap a little bit again. I don't want to make a mess, so we're going to be really careful about this. Again, make sure it doesn't spill over. We want to get all that gas released. Just tap very, very gently, as many times as you need to. We're going to go ahead and we're going to check the pH again. I have my other strip of pH paper here. I'm going to throw that in there. I can take my transfer pipette or my spoon. We're going to scrape that top layer off, just make sure it's still the layer we don't want. And we're going to drop it on the pH paper. So it's up to you guys really if you wanted to do the second sodium bicarbonate wash. As you guys can tell, we have a pH about 10 compared to the 8 before, and that's a little bit high maybe for what we want. It's really personal, depending on how much wintergreen you like. So this is pretty good. I'm going to go ahead and I'm going to go grab our FTIR just so that we can make sure that everything looks right. We have all the correct components. just before we go ahead and let this set. Alright, so I have the IR. We're just going to go ahead and we're going to look at it before we put it back into the heat to get rid of that dichloromethane flavor that we don't really want in here. So as you can see, I have my FTIR, so I can see nice spectroscopy there. Everything looks good. Got some good bonds. Then we go ahead and I'm going to pop this onto a hot plate. Let that flavor go away a little bit. So actually, while it's on the hot plate, just to make sure that it also heats evenly and gets rid of all of that dichloromethane flavor, we're going to go ahead and we're going to add just a couple of boiling chips into that. Just sprinkle them in there. Make it look nice and pretty. Okay, so I've taken the product off of the burner. As you can see, we have a more solid product. You might have a little bit more oily. I've just taken a section of this after removing the boiling chips and preparing it for NMR. I'm going to add some deuterated chloroform, just right like that. Doesn't that look pretty? So we can now look at this through the NMR instrument, and we can make sure that it still looks presentable, and you can still see that winter greeny color. And so for the rest of this, I'm going to go ahead and add some diethyl ether, and we're going to get that ready for GCMS. So I just used my transfer pipette to go ahead and add a little diethyl ether. You want to be careful because it's slippery and tends to get everywhere. But as you can see, our product is now ready for GCMS. I think it looks good. Let's see what they think.
Hi guys, welcome back to the Science of Baking. I'm here with the creator of that last wonderful recipe that we went over. And we're going to ask her a few questions about how she came up with the recipe and how those of you out there who are interested can come up with your own. So I actually have here a list of questions from the viewers. And the first question from @JKT is, why did you decide to run the recipe on reflux?
Well, I chose to run the recipe on reflux to decrease the baking time. While running a recipe on reflux does decrease the extent, we chose to run it on reflux because it is so much faster that it's worth it.
Okay, so our next question from @Kiki is, why did you decide to use a catalyst in your crust?
I chose to use a catalyst in my crust because the catalyst, as shown in the energy diagrams, will lower the activation energy, once again speeding up the baking process.
So it's actually very efficient this way.
Yes.
So our next viewer, @JPollard, wants to know, why did you use a pH extraction, and what pHs in particular were you looking for? How did you decide that?
For the pH extraction, I used sodium bicarbonate to increase the concentration of OH minus and the pH to an ideal range. As you can see, in the percent concentration versus pH plot of methyl salicylate, the wintergreen flavor is strongest at pH less than 9.8. To purify that flavor, I wanted to get rid of excess salicylic acid, which is soluble in its base forms, which are dominant at pH greater than 2.98. However, to preserve as much methyl salicylate as possible in our final product, we went for a pH range between 2.98 and 9.8. This removed salicylic acid from the organic layer and put it into the aqueous layer, and only left methyl salicylate behind in the organic layer.
Wow, that's a very well thought out response.
Yes, it is.
This recipe and tried it on his own and shared it with his friends, and he sent us in these spectra of results of what they thought. And a couple of them said it wasn't as minty as it possibly could be, and they would have liked more flavor. What do you think when you look at these results?
Well, as shown by the GCMS spectra, peak 1 has the mass peak at 152, which corresponds to the methyl salicylate molar mass of 152.16 grams per mole. Moreover, the cation fragmentation pattern matches up with the pattern expected from methyl salicylate. The key peaks are labeled on the spectra, as you can see, peak 1. With these analyses, we can conclude that peak 1 is methyl salicylate. The IR and the NMR spectra support this claim, as discussed on each analysis shown. Not only do the GCMS show 100% purity, but we also used it to calculate that he only got a 26.4% yield of the minty green flavor.
So where do you think he might have lost some of that flavor?
He could have lost some of that flavor in the second pH wash, and to prevent that, we could have done a NaCl wash instead, because this would have increased the solubility of salicylic acid without increasing the pH anymore.
Oh, that's actually a really interesting point. Thank you.
Thanks.
I hope you guys enjoyed that. I think we learned a lot today, and I hope you guys all go out and try to make your own Ethyl and Salicylate's Minty Fresh ice cream pie.